Welcome to today's webinar, Mastering Storage Chaos for CAE and AI. On today's agenda, we're going to talk a little bit about TotalCAE if you're not familiar with us, and then talk about standard storage design options for CAE as it exists today, both on-prem and cloud. Then a high-level overview of AI and how that creates new storage challenges to support AI workflows for simulation data. We're going to look at the NVIDIA reference architecture to kind of show that in practice and how we take that simulation data to get it into correct formats and how we do AI training. How we see a lot of clients right now organizing their data as a first-time journey and what the end state for an optimal workflow will be if you want to keep your data for AI training. A little bit about AI versus design of experiments from a storage strategy point of view. And then how TotalCAE helps clients with storage challenges of AI so far. So if you're not familiar with TotalCAE, basically what we do is we're a high-performance computing managed service. We provide software, hardware, and other tools that help you reduce your simulation time by up to 80%. And we do that by providing turnkey clusters that we manage in your data center, all the way from the hardware all the way up through the time you submit the job, all of your applications and such. And we do the same thing in the cloud, in your cloud subscription. We support hundreds of applications, and we make it really 1, 2, 3 simple to submit, manage, and consume high-performance computing, whether that's in your data center on a cluster, in the cloud, in your cloud subscription, or both. And everything, if you have any problem, we do have a help desk that helps solve any issue that you might have from the time you submit the button to the time you get back. Basically, everything in between, that's TotalCAE's responsibility to make sure that your engineers can keep their simulation deadline. So I want to talk a little bit about CAE storage designs. Before we talk about AI that makes these a little more challenging, we all see simulation from, as long as we've been doing this, almost 20 years, have always had some we've always had storage challenges. And there's basically 4 major storage designs that people do based on 4 criteria. And it's like, how much capacity do you need? There's short-term versus long-term. Short-term data that's being generated on clusters and clouds needs high-speed, fast data, while long-term data, all your finished results and everything, those could be on slow storage. You may not need it very often. So, and then the amount that you need for both of those may be different. So what are your capacity needs? The other thing is storage fails. And if your storage appliance fails, how fast do you need to get the data back? And how much data would you be willing to lose? Those are called RPO and RTO. That has a selection in the design. Then your budget. Everybody, it's always nice to have the most optimal solution, but often those aren't in your budget. So what can you afford to do? And then what are the corporate IT capabilities? Corporate IT often will have backup solutions. They'll have off-siting solutions. They'll have methods for even for a high-speed storage. But it depends on corporate IT, and sometimes corporate IT's capabilities, the amount of data CAE teams can generate, sometimes dwarfs the entire backup capacity, nearline capacity of enterprises. But we're always in the same kind of boat. We're taking a small amount of input, putting it on a cluster, and generating a large amount of output and trying to distill that down into a small amount of storage that we have access to. So, that is the challenge of CAE storage. It's always been there, even pre-AI. So a common, what we call 3-2-1 storage design is kind of here. And what do I mean by 3-2-1? Well, when we're referring to wanting to make sure that you don't ever lose your engineering data that you want, most of the time you want to have 3 copies of your data on 2 different types of media, and at least one of those being offsite. That will protect your engineering data, whether those are just the inputs or the outputs or your results, under most conditions. And that's, if you Google 3-2-1 backups, you'll see there's a lot of data out there on this design concept. But it's called 3-2-1 for that reason. And typically you're going to have, as an engineering department, some amount of storage data. Let's say 100 terabytes is pretty common from a mid-tier. 100 terabytes of primary storage where you run your jobs, where the outputs are, maybe you keep the final results on there as well. And many clients will have what's called the scratch area where they're working on their data. They're working on models and running jobs, and they don't necessarily need to have that like copied off to the cloud and stored forever. So we call that work in progress. So you may only need, you have your work in progress, and then you have the final results. Usually you have the, final result, the design was chosen, you put it in your report, you want to have all those backed up. And that's usually in a separate area. And typically then there's a second copy of that data made, often in the same data center, so you can get very fast recovery if the primary storage would die. And that's usually larger than your primary storage. So you can archive for years your data. You can be up to a petabyte of storage. And some people do like to keep a second copy of all the work in progress optional. And finally, the data is put into the cloud, off-site typically, or some type of other data center storage, depending on what IT has. But that is like the third copy of your data. So if your entire building would burn down or hit by some kind of natural disaster, tornado, there's still some copy of your data geographically far away that you can restore from. So that is the most common workflow that we see on mid-tier to enterprise customers. The technology you use, it could be NetApps, it could be just simple storage appliances with a direct attached storage. There's the technology, you can put a lot of different technology that we sell or support, or the enterprise IT supports, that can do this 3-2-1. But this is kind of the optimal design. But often customers have a constraint where they make so much primary storage generation, they can't really afford to have or don't want to pay for a complete second copy of all of that data. And so kind of a secondary solution is to only copy the inputs and maybe just your final results to the second copy and then offsite. And many enterprise IT groups that provide backup solutions, they may not be able to back up 100, 200 terabytes of your engineering data, but they could do in the small single-digit terabytes or double-digit terabytes. So in that case, you could always regenerate your simulation results if you needed to in an emergency, but at least you have all the inputs, which are typically pretty small. Input files are in the kilobytes, megabytes, while the outputs could be in the gigabytes to, multiple hundred gigabytes. So this is quite often a third kind of option that lets you still have 2 copies of your data, maybe not all your results though, and be able to offsite those inputs and maybe a subset of your most important results to the cloud. A third option on smaller clients, they only have their PC and they have a cluster. And while the cluster could easily have 100 terabytes in an affordable form factor for small customers, they only take the most important data and they put it on their PC, and often corporate IT has some network backup that backs it up for them. So on smaller clients, this is a pretty common scenario. They're not able to, afford, a $80,000 to have multiple copies of their data, in the hundreds of terabytes or petabytes, and so this is commonly done. A final option is that you could just have your cluster storage and have it directly backed up to the cloud. Now, there's many corporate IT tools that can back up servers and filers and stuff and want to do cloud. There's Veeam and Rubrik and many of these types of things. But the problem with some of these solutions is that it can possibly never catch up. It's trying to copy lots of data to the cloud. They still usually have to be configured to probably only do some subset of your data, because if you're trying to do hundreds of terabytes, it just can't catch up and keep all the data synchronized to the cloud. So we end up helping clients customize their backup agents or copy agents so that they can still have at least a second copy of the data, and hopefully keep up to date on those backups. The other challenge is if you lose your primary storage filer, things break, things might go down. It can take a significant amount of time to restore hundreds of terabytes from the cloud back to your on-prem solution, and there's often a charge from the cloud vendor to egress that data. So if you need to be up and running super quickly, it is always good to have some type of emergency storage to run on while you're waiting for those restorations. So these are all things we kind of go over on those 4 design criteria when we're trying to decide what is the best strategy for a company. Now, many customers have cloud solutions or are all in cloud, and for those customers, the cloud has a lot of storage services which make this vastly simpler and almost transparent. So on Azure, for example, we have Azure NetApp Files. It has the ability to give you just a single, basically, directory. It looks like a volume. And then it's able to migrate data blocks that you're not using automatically to cheap storage for you. It's able to then also do replication across multiple geographies. And for data that you're actively working on, it keeps it in very fast disks, and you don't have to know anything about what's going on. You just run your apps, and all this is really transparent. So the cloud definitely has some very nice cloud transparent solutions that enable you to have the kind of the best of everything just as a service fee. Now we're going to talk a little bit about how AI has made it a little bit more challenging from a storage perspective and data management. So at a high level, the way machine learning and AI workflows work with CAE, it actually works with the same for any kind of data, not just CAE, is you have to gather training data. And what's training data? I mean, it's running your simulations and getting the actual answers. I have these inputs for these geometries. This gave me this kind of output when I ran it. You need to have a bunch of that data. So you need to gather all your data. Typically, when you look at your data, there's going to be some outliers, like things that are like just out there that aren't really, you don't want to consider trained. You may need, and you want to remove any outlier data so the machine learning algorithm doesn't think that is like, hey, that's great, that's what that is like common, because it's trying to infer data. So you kind of remove the outliers from your simulation data. Might be as diverging or whatever. That data you're going to remove. Then you usually will hold some percentage, 20% is considered a best practice, of the training data that we're going to later use to see if the predictions are accurate. If you give it all your data, you're not going to be able to know is this prediction even accurate based on other simulations. Then you're going to train the model on the 80% of the data you have, and then we're going to take that 20% of the data we withheld and then see, does the model predict it correctly? And if it does, then you could have a little higher level confidence on the prediction it has. If it's way off base, then we go back to the beginning, gather more data, try to, and basically repeat until you feel comfortable that your model will predict what you wanted. So this is kind of the high level workflow. And that creates some additional challenges that we really haven't had. In the past, you didn't really keep all of your data because you weren't trying to train a model with it. So you might have kept the best result, the end result, whatever the final design was, but not everything that led up to it. So we need to do an AI workflow, we need to be able to preserve all of our data. And you do not need typically that data on high-speed storage because you're just storing it for more like an archive to train. But while you're training, the training does need extremely fast access to the storage that these data models. So again, you're going to have often a couple different classes of storage. One to save all the model for the long term that's cheap, and then the high-speed storage to do the training. You also need to be able to keep track of the data that went into the model. And so you can't, if you have just a directory with thousands of simulations in different folders, you're not going to be able to track that. And when you train that model, you really want to know what went into it. Not only for just knowing, was there something mitigated, but compliance and so on. So we need to be able to have maybe our data more organized than often CE teams are not really worried while they're running the simulations. They're just trying to get the answer. You're not really worried for the long term. Do I need to keep everything that I've ever had and keep it categorized and organized in a way that I can feed the AI engine? Finally, that you may not always be, you might be doing, you have the, not just the simulation results, but the geometry and other items that you may not be keeping or not are separated from the FEA results when you're all done, when you're storing this stuff. So though the AIs need this kind of data kept and kind of, as we'll see later in the NVIDIA architecture, we need to be able to keep these things together in a way that the AI can ingest it. So these are all things that many customers do not really worry about on a day-to-day basis while they're doing their CAE analysis, but now that they're being called on to do training or interested in to train models to infer, to basically stop having to wait on long time for simulations and just infer it in a couple seconds, we need to now start handling all these things. And so, I'm going to show kind of an NVIDIA reference architecture. There's many, many tools. There's now a lot of commercial tools that will try to help you with this from all the different vendors. So I just picked NVIDIA just because it's kind of made it easier to explain on how you can do AI training. So they have kind of the 4 blocks that I showed before. They have your data, the geometry, and the results. Then you do the training, and then you can infer from the training. Then you can visualize that. So they have these components, and these are all little, like different software pieces. But we're going to focus a little bit on the data and how do you get it into that first training box, the Physics Nemo Curator. So like we mentioned, we have to have enough data. But how is the data need to be formatted? Every single tool is going to be different. At a high level, they all need the same things. They need the geometry, they need the results. But in this case of Physics Nemo, in the documentation, it says, okay, here is the format that we would like for this external arrow problem. You know, you have your geometry, solution data, volume mesh, and surface mesh data. This is looks like open foam data, and you can get this from foam to VTK and other utilities that foam includes, but it wants it kind of in this format. So first you got to get all your data on all your runs, and then you got to get it into this format, and then you can feed it into Physics Nemo just to have it start being able to prepare that for the training. So this is just like a real example of your data structure of how it would look on disk. You're just going to have, of course, not one run. You're going to have 1,000 runs or whatever is needed to do your training. So many customers on their first journey, they don't have all of their past data. So now we have to rerun the data for maybe a problem we're trying to solve. We're going to run all those simulations to get a good baseline. We're going to need to store it and one of those many different storage architectures I mentioned before, and probably going to then need to make sure we have enough metadata that we can extract that data into the required format, like I just showed in the previous slide, then do the training and inference and everything that was shown afterwards. But that isn't really the optimal solution. The optimal solution would be, as going forward, if you decide that this is what you want to do, we're going to run our simulations. We want to automatically store them and tag the data that we need so that we can formulate it into the training format. And then you might use multiple different AI tools, and if so, you want to be able to extract that data out of your simulation repository and have that metadata help you organize it in a way that can put it into the way the tool needs. And you want to have this kind of be all automatic so that you're not having to go back and find data. You can look at data the organization might have or other teams have generated and have enough information to know, do I want to use this in my machine learning model or not? We do have some, in this storage issue wasn't just from AI. Before AI, we've had the design of experiment tools for many decades, and while they're similar in their storage challenges, they are different. So in the design of experiment tool, you're usually trying to see the relationship between, hey, I'm changing parameters, certain parameters, what are the results, what's the sensitivity of those parameters, and kind of looking through the design space, but in a very deliberate and structured way. And most people, once they get they understand all that, they're not keeping all of the design of experiments, thousands of runs it was doing. Those are all just thrown away. But you do need more storage than normal for while you're running the job. AI machine learning, it's just predicting based on past data. So you need to have all that past data, but it's not generating new data. You're taking that model and you're getting the result that it's inferred. And so a little bit different. And it does also have a different goal. It's more a prediction engine than it is trying to understand sensitivity analysis and such. Data generation, again, all the data for a DOE tool is generated basically during the run. There are now some hybrid solutions that combine past data with the real data it's generating, which is pretty interesting. But historically, the data that the DOE tool is generating on the fly during the study. Machine learning, however, is using all past data. It's not creating a new data and running simulations. It's just taking the past data and then trying to basically predict the future based on the past. The data volume for DOE tools are small to moderate. You don't need a ton of, you might be able to quickly come upon an optimal design, with a smaller amount of data. Maybe get lucky and you get the design space right off the bat. But machine learning tools need a large amount of data to make sure those data, the prediction is robust. So you can't take four simulations and boom, you're suddenly predicting a huge design space. And on the data results of the storage, like we discussed, while you don't really keep pretty much any data from a DOE tool for the most part, outside maybe the final design results that you inferred from what it came up with, but on machine learning, we are keeping all of the training data and the final model, and all of that needs to be stored. So how do we help people with the things that we talked about in this webinar? So TotalCAE does not actually do the machine learning for you. So that is still in the realm of the engineer. And so what we do is we provide all the IT solutions for sure that or configure your cloud storage solutions to be able to do all those data pieces that we talked about, and then we help clients decide what's the best solution. We do have a tool called Data Marshal that has historically been just used to store all simulation data. So users wanted to keep all their data, they'd submit it to the cluster, we'd automatically store it, catalog it. I'll show a screenshot of that in a second. That tool ended up being kind of handy to now for AI, because we can go extract all the, we do have customers that are using our Data Marshal tool, do have all their data, they never even knew it. They're just submitting jobs and it's being stored, and now they're able to use that for AI training. So it's pretty handy. Now, that is an add-on to our normal subscription, but it does store all your data in an object store or commodity storage, and so customers who have had that are actually benefiting from that at the moment. It was kind of hindsight's 2020, I guess. But if you have your own storage solution, because we can easily integrate with whatever storage simulation data repository you have, we can help you get your data pushed into it at the end of every single job, and we can help you with scripts and code that will manipulate that into the way you need. So we do integration work like that. And if you want to be able to take your existing data and you're like, hey, I need to automate, being able to get it into the various formats like I showed earlier that the training needs, we can help you with that. We can help you get the data results you have and reorganize it for the different CAE tools through automation and coding. So definitely can help with that kind of work. We have our own software team, and they can help work with these projects on special solves that we can work with you on. And that Data Marshal tool that I mentioned that many of our customers have adopted, it mainly is just a simple way to organize data and search on it, including custom metadata. It just happened to be that if you are a client that has Data Marshal, you can now be able to use that to find the data you need, extract it, create new tags that will help you organize it in a way that will make it simpler to do machine learning. And in some cases, maybe we need to keep, if you are deciding to only keep the inputs in the Data Marshal, you may want to add on options to now store all the data. And because we store this on commodity cheap storage, it makes it relatively cheap, maybe compared to like trying to store results into PLM or things, to store all that data. But in any case, if you need any help on deciding a storage strategy, you have some tool that you're trying to work with right now and running into any of the challenges of this webinar, feel free to email us at info@totalcae.com. Happy to do one-on-one on your particular situation and see how we might be able to help you, or at least put you in the right direction.